Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Today we are going to discuss about the topic of number system. So we know that there are different type of number systems, nothing but natural numbers, whole numbers, integers, rational numbers and irrational numbers, real numbers also. Now today's concept is we are going to discuss about the topic of surds. What is the topic? Going to discuss about the topic of surds. So before that, we know already what are natural numbers, whole numbers, integers and rational numbers. So counting numbers are called natural numbers. Natural numbers including 0. Whole numbers, all positive numbers, all negative numbers including 0 are called integers, and rational numbers are nothing but the numbers which can be expressed in the format of p by q, where p comma q are belongs to integers and q does not equals to 0. So p by q format of numbers are nothing but rational numbers. Now the numbers which cannot be written in the format of p by q are called irrational numbers. Okay, the numbers which cannot be written in the format of p by q form are called irrational numbers. Like examples, we can take that root 2, root 3, root 5 and so on. Now we are going to discuss about the topic of surds. So here you should understand one sentence, that is, all surds are irrational numbers, but all irrational numbers need not be surds. For example, when you take the irrational number pi and e, eccentricity, these two are irrational numbers, remaining all are irrational as becomes as a surds. Okay, now what is the definition of surd? Is there any separate definition of surd, or we have to go with the same definition like the numbers cannot be written in the form of p by q? Yes, there is a separate definition of the surd, nothing but the numbers which are in the format of nth root a. If a is a positive rational number, n be a positive integer. If you take that a is a positive rational number and n be a integer, if the number which can be expressed in the format of nth root a is called surd. Example, we can take that cube root 5, 6th root 21. These are all becomes a surds which are in the format of nth root a. Here n is called order of the surd. What is that? N is called order of the surd and a is called radicand. A is called radicand and nth root is called radical sign. Nth root is called radical sign, and while you are going to express this nth root a in the format of exponents, we can write this one as a power 1 by n. A power 1 by n. Similarly, let us go through the example. Here I have given that cube root 5. Cube root 5 can be written as 5 power 1 by 3. We are not changing the radicand. Radicand we are writing as it is, but the order we are going to express in exponential form. That means cube root, radical sign we are changing or we are converting into exponential form. It becomes whole to the power of 1 by 3. Same way, 6th root of, you have to read it as 6th root of 21. It can be expressed as 21 power 1 by 6. I hope you understand. That means whenever you are observing that for a is any rational number and n is a positive integer, it can be expressed in the format of n through a is called surd, where A is called radicand and N is called order of the surd. Order of the surd. Clear? Yes. Now let us see the types of the surds. Now types of the surds based on the terms and based on the order. Now let us discuss about the surds based on the order. Based on the order, that means n value. While we are taking the definition, the n value cannot be 1. Check here. The n value is not equals to 1. When you take the n value is 1, we cannot express that. We cannot write in the format of radical form. Nothing but surd form. Okay? Minimum 2 we have to take. 2, 3, 4, 5, 6. Any number, it can be the order except 1. Right. Right. Based on the order, first one, quadratic surd. Order 2. Order 2 surd is called quadratic surd. Nothing but square root of 2, square root of 3, square root of 5 and so on. Whenever if you wanted to express in the exponential form, square root is nothing but 2 power 1 by 2. Square root 3 is nothing but 3 power 1 by 2. 5 power 1 by 2 and so on. Clear? So this is the exponential format of the square root. Root over 2, root over 3 and root over 5. And here one more thing, that is, while you taking the square root, the quadratic surds, the order is 2. That means the radicand cannot be in the format of square number. Radicand cannot be square number because of order 2. If the order 3, the radicand cannot be cube number. Order 4, radicand cannot be expressed as power of 4. Clear? When you are expressing like that, for example, let me take that 5th root of 32. 5th root of 32. I am writing that 32 as 2 into 2 into 2 into 2 into 2. 5 times of 2. 2 2s are 4, 4 2s 8, 8 2s are 16, 2s are 32. Nothing but 2, 5 times multiply itself we can express as 2 power 5. That means this one I am going to express as exponential form, 2 power 5 whole to the power of 1 by 5. Now using the laws of exponent, a power m whole power n format a power m into n. So denominator 5, numerator 5 can be cancelled. 2 power 1, 2 power 1 is nothing but 2 is a rational number, which is not a surd. So while you are expressing about the surd, that radicand cannot be expressed as exponents as its order. That means for a quadratic surd, the radicand cannot be a square number. For cubic surd, radicand cannot be a cube number. Now second one is cubic surd. Cubic surd means order 3 surd is called cubic surd. Example, cube root 2, cube root 3, cube root 4, cube root 5. Because these are all, while you are observing the radicands 2, 3, 4, 5, they are not a cube numbers. What about the cube root 8? Is it a surd? It's not a surd because 8 can be expressed as 2 cube. And the cube and whole to the power of 1 by 3 can be cancelled. Answer is 2. So cube root 8 cannot be surd because the radicand we can express as cube number. Okay? Right. Now biquadratic. Biquadratic means order 4. Order 4 surd is called biquadratic surd. Clear? Yeah, 4 through 2, 4 through 3, like that. Yes. Now let us move on to the types of surds based on terms. So previously we have discussed about the based on the order. Now based on the surds. Okay. What is that simple surd? First one is simple surd. Simple surd is nothing but only one term. A surd is having only one term is called simple surd or monomial surd. Simple surd or monomial surd. For example, root over 5 or 2 root 5, 3 root 7. These are all simple surds only because they are having only one term. Single term. Okay. Now coming to binomials here. Binomial surd. A compound surd consists of two terms. While you are taking that 3 plus root 3 plus root 5, there are two terms. So it is a binomial surd, or we can write as 2 plus root 5. It is also a binomial surd which is containing two terms. Okay. Now coming to the trinomial surd, a compound surd consists of three terms. So based on the term, only one term can be called as simple surd or monomial surd, two terms nothing but binomial surd, and three terms are nothing but trinomial surd. Clear? Yeah. Now coming to mixed surd. Now mixed surd is nothing but the rational and irrational numbers together are called mixed surds. Simply see here, A is a non-zero rational number, root B is a monomial surd, then A plus or minus root B and A root B are called mixed surds. For example, 3 plus root 7 is a mixed surd where 3 is a rational number, here root 7 is a surd, okay, or simple surd. Same way, 3 root 7 which is also a mixed surd, combination of rational and surds or irrational numbers, nothing but. Clear? This is nothing but mixed surds. Now compound surd. Compound surd means the sum or difference. Sum or difference of rational number, one rational number, and one or more than one irrational numbers together taken as compound surd. Okay, no? A rational number and one or more surds is called a compound surds. Like 3 plus root 15 plus root 17, which is a compound surd because of combination of rational and irrational numbers together we are writing. Clear, children? Yeah. Now simplest form of a surd or pure form, okay? Pure surd or simplest form of a surd. Pure surd or simplest form of a surd. For example, root over 50. Let us try to write its simplest form. How we are writing the simplest form? I am just expressing the 50 as its product of primes. Now I can write it as 5 into 10. Am I right? 50 can be written as 5 into 10. Now 10 can be written as 5 into 2. Okay. Now try to apply the root over 5 into 5, 5 square. Can we write 5 square? Yes, into 2. So try to write that separately the square root. Here square root cancel, here 5 will be, now here root 2. So this is the simplest form or pure surd of a surd. Okay. So before that we need to discuss about some laws of surds are there. For example, root over A into root over B, nothing but root over A into B. This is one of the law of a surd. That means order is equal here. See, square root, here also square root. Order is same, but the radicands are different. So for this, for example, we can take that root 5 into root 7, we can write it as root over 35. 7 5s are 35, root over 35. We can do it like that. Okay, but cube root 5 into root 7, we cannot say it as cube root of 35 because of order is different here. While you are observing here, order is same. We can directly multiply the radicands. Now same way, mth root a into nth root a is nothing but mnth root a. Both are having the same radicand. First one having the same radicand a, second one having the same radicand a. Even though order is different, how we did that? We just multiply the order this time. M into nth root of a, mnth root of a. Okay, na? Mth root a, nth root a is nothing but mnth root a. So mostly these two are very, very important. And here also you should know about it. Root a plus root b. Both are same surds. Order is same. Similar surds we can call it. Okay, na? Order and radicand both are same. We can call it as similar surds. Order is same, radicand is different. We cannot say that similar surds. Okay? Yeah. Root a plus root b is not equal to root over a plus b. This is only happen for multiplication and division. That means root A by root B is nothing but root over A by B. Multiplication and division we can do it, but addition and subtraction we cannot do it. Clear? Yeah. Now this is about the pure sort. We can write it as pure sort. See, convert this one into pure sort. 2 by 3 into root over 7 into pure sort. Sorry, actually pure sort into entire form. Okay. Now, while you are observing here, 2 and 3, 2 by 3 is a rational number, root 7 is a surd. How can you do this one? Very, very important this one. Just look into it. I can write this one as 2 by 3 as root over 2 by 3 into root over 2 by 3. Can I write like this? Yes. Or else, for understanding this one, I can write it as 2 by 3 whole square under root over 2 by 3 whole square. Square root can be cancelled. We can write like this, right? Now in the next step we can write it as root over 2 by 3 into root over 2 by 3 into root 7. As we discussed, as root A into root B is nothing but root over AB, A into B. Same way, if you wanted to write like this, so 2 by 3 into 2 by 3 into 7, which is nothing but 2 into 2, 4, 4 sevens, 28 by 9. This is the entire form of this pure surd. Okay, so simply for understanding you this one, while you're taking that rational number into the square root, rational number, this rational number I am going to take into the square root, that rational number becomes the double in square root. That means 2 by 3 becomes 2 by 3 into 2 by 3. If you take this rational number into the cube root, for example, 2 by 3 into cube root 7, if you wanted to take this 2 by 3 rational number into the surd form, into the cube root, it will become cube root of this rational number becomes 3 times 2 by 3 into 2 by 3 into 2 by 3 and one more 7 here. Okay, no? I hope you understand. Now try to check the next problem, which is very, very important. See, simplify this one. How we are going to simplify? As I have told you that whenever the order is same, we can directly multiply the radicands. But while you are observing the denominator order is same, but the numerator while you are observing, first one is order is 3, second one order is 6, which is different, entirely different. So in this situation, how can we do this? Let us try to simplify the denominator first, because both are having the same order, 6. So we can directly multiply the radicands, 3 into 8. So 3 8s are 24. Okay. Now coming to the numerator, I would like to change both of them into the same order. So what is the first one order? First term order is 3, second term order is 6. Try to find the LCM for both of them. What is the LCM of 3 and 6? Which is nothing but 6. See here, 3 1s are 3 2s are. There is no common factor between 1 and 2. So 3 into 1 into 2 is nothing but 6. LCM of 3 and 2 is 6. Now try to change the order of both of them into 6. That means second one is already 6. Try to change the first one as 6. For that, I am expressing this one as in the format of exponential form. Cube root of 2 I can write as 2 power 1 by 3. Now this one 6 power 1 by 6. Now the denominator should be 6 because of getting LCM is 6. So I am trying to multiply 2 into 2. Okay. Now this one 24 power 1 by 6. Okay. Now this is 2 power, multiply the numerators and denominators. So numerator is 2, denominator is 6. 2 by 6 into 6 power 1 by 6 by 24 power 1 by 6. Okay, so here 6 power 1 by 6, 24 power 1 by 6, here only 2 by 6. According to the law of exponent, we know that a power m whole power n is nothing but a power mn. Same way, a power mn also we can express it as a power m into whole power n. Same way, I am writing this one as 2 square into whole to the power of 1 by 6. Okay, na? Now this one 6 to the power of 1 by 6. Denominator is 24 to the power of 1 by 6. Now, if the exponents are same, according to the laws of exponents, we can multiply the bases. So, 2 square into 6 whole to the power of 1 by 6 by 24 power 1 by 6. Same way we can write it. 2 square value is 24 and into 6. 4 into 6 is 24. 24 power 1 by 6. Denominator also 24 power 1 by 6. After cancellation, we will get the answer is 1. Okay? See, this way we need to simplify this form. Whenever we are getting the dissimilar surds, we can simplify in this manner. Okay? Yeah, that's it for today, children. Thank you, one and all. Have a nice day. Bye-bye.